Right, so in this video we'll see polar coordinates part 2. So this is polar coordinates part 2. So let's remember that we've been working with this Cartesian coordinate system, and this coordinate system implies that we have both x and y. These are the two variables that are going to tell us where we are in space, right? And if we look at our coordinate system, the x value would be the horizontal distance. So x is the h distance from origin, h distance from O. So from the origin, so let's call this point right here, let's call it the origin. So x implies a horizontal distance from O, and y implies a vertical distance from O. Okay? So if we have this value here, this variable, well, this point in space, sorry, has both a horizontal distance and it has a vertical distance, okay? From the origin. So we can call this point, we'll have this coordinates right here. Okay, for what I was teaching you, the polar coordinate system, so let's put this in blue. So when we are talking about polar coordinate system, we too are going to be using two variables because this is two-dimension. Whoops. We normally put r first. So r, comma, theta. Okay? So this thing is very simple. We have our origin, so let's call this O. And r implies my total distance from O. And theta implies my angle. So for example, if I take this point right here, r would be this distance right here. Let me put that with another color so that it's distinguishable. R is this distance right here, and theta is the angle that this point forms from the horizontal. Okay? So now, let's see how we can change from this coordinate system to this coordinate system. Okay? So it's very super simple. Let me draw it big here. Okay? You know what? Let me use another color. Let me use pink. Okay, so put my coordinate system right here. So imagine that we have this point, okay, with a given x value and a given y value, okay? And we can trace the polar coordinates just as easily. We can trace this distance right here. This would be r, and this would be theta. Okay. So the way that we can change from one coordinate system to another is rather simple, and you guys should already know how to do it. We can use it. We need to use the Pythagorean theorem. So Pythagoras. I think that's how you spell it, or with a y. I'm not sure. Okay, but el teorema de Pythagoras. So how do we get, if we have both r and theta, how do we get x and y? Well, it's very simple, right? What we do to get x, look at this. Okay? This should be evident how to get our x value and our y value. If it's not evident, I'll write it down here. X will be equal to my magnitude of r times the cosine of theta, and y will be r sine of theta. Okay? So how do we change? That is simple enough. How do we change from, if we have y and x, how do we change to r and theta? Well, that still, we use the Pythagorean theorem. R is equal to the square root of let's start with x. X squared plus y squared, and theta is equal to the inverse tangent of y over x. Okay? Please remember that this angle will always be giving you the one with respect to the horizontal, right? So you need to take care with your trigonometry so that you always use this absolute angle, the angle measured from this horizontal distance, from this horizontal axis all the way to your r, to your hypotenuse, okay? So this is basically, we're done with polar coordinates. We'll be using them with circular motion, okay? But I just wanted you guys to know how do we switch from one coordinate system to another and vice versa, okay? It's just with simple trigonometry, okay? Thank you guys and see ya.